And here's the video for lesson 4. For you guys, maybe it was a couple minutes. For me, it's been literally 30 seconds since the last video. We're going to power through this one. This section is actually really short. I know that. So it's about asteroids, comets, and meteoroids. So asteroids are rocky objects that are found between the orbits of Mars and Jupiter. So on the right side, we see a picture of Jupiter out here, and Mars is out there. This actually is a lot more closer to scale than the other picture was a while ago. You see all these crazy things going around. These are all asteroids. We believe they're remnants of the solar system. When the solar system formed, we think these are leftovers. Jupiter does a pretty good job of kind of keeping them in this small area. But sometimes Jupiter can like fling things. And the reason why is if things get too close to Jupiter, they get pulled in really fast with its gravity. But then what Jupiter can do is instead of if the object is heading towards Jupiter but not quite directly towards it, it barely misses it. And that means it's going super fast and it missed Jupiter, so it's going to get launched out somewhere really fast. So most of the time Jupiter protects us. Every once in a while it shoots one really fast somewhere in some random direction, but oops. So those are asteroids. They were in between Mars and Jupiter. Comets are icy. So asteroids are rocky. Comets are icy. They still have a little bit of rocks in them, but they're more ice. It is still in orbit around the sun, but they have a highly elliptical orbit that passes really close to the sun and then really far away, farther than Pluto maybe, in some cases. So if you try to follow this, it goes from 1986 to 2060, I think. Let's wait for this. Yeah. And in 1986, a comet was right by the sun. In 2020, the comet's out here. So right now it's out there. And then in 40 years, it'll finally be back over here. That's how long it takes for these comets to go around the sun. You'll notice that compared to the planets, they're a lot more oval shaped. That's because comets have a highly elliptical orbit. Now, a comet does have a small solid part, as I said. It's like a rocky part in the middle, called the nucleus. It's usually no more than a few kilometers in diameter. The atmosphere, or the coma, of a comet heats up and grows larger as the comet moves closer to the sun. So pretty much as the comet moves closer to the sun, the icy part kind of starts to burn up and makes a cool atmosphere like that, like coma. So we got the nucleus and we got the coma. It also has tails of the material flying off and stuff like that. Now there's two places that we can get the comets from. There's short period and long period comets. Short period comets come from some place called the Kuiper Belt, that's how you pronounce that word, Kuiper Belt, that are located beyond the orbit of Neptune. So if you go to Neptune, go a little past Neptune, that's where the short period comets are coming from. Okay, those are the ones that take like around like 100 years. Those are the short term, the ones that take like that long. Then we have the long-term comets, which have periods longer than 200 years, which means it takes more than 200 years to see again and to go in a cycle. And they're thought to originate from something called the Oort cloud, and we will see what the Oort cloud looks like in a couple slides. In 2005, we found something in the Kuiper Belt we called the Kuiper Belt object. We gave it a temporary name, 2003 UB313. 2003 was the first time we observed it. 2005 was the first time we confirmed what it was. However, nowadays, it's actually called Eris, and this is larger than Pluto. So another reason why Pluto is no longer a planet. I mean, back in 2005, we found something that is bigger than Pluto. We will see what that looks like in a second, but if you see here, this is the sun. This is the planetary region. Okay? So this is about how far all the planets are. We go out farther, and this is where we get the Kuiper Belt. Remember it said past Neptune? It's a belt of short period comets. But then if we go farther out from the sun, we get to something called the Oort cloud. And this is this sphere of hypothetical comets that are surrounding the sun. We are not 100% sure if the Oort cloud exists or if there's just a decent amount of comets that go that far. But our current hypothesis says that all around the sun in a sphere, Really far out there, there's a bunch of comet-like objects and asteroid-like objects that are still kept in place by the sun's gravity. They're just not big enough to form planets or anything like that. We're not 100% sure if that's the case, but we're pretty sure it is. The Kuiper Belt, we're 100% sure that exists, but the Oort cloud, we're not exactly sure. So I've been saying Pluto's not a planet, and we just found out Eris is larger. Here's a couple other objects that would kind of have to be considered planets if we include Pluto as a planet. They're called trans-Neptunian objects. It means they're past Neptune. So all these guys are past Neptune. This looks like an egg. I think one of these looks like the Death Star from Star Wars. It might be this guy. But yeah, these are all bigger. This is bigger than Pluto. These are all similar size to Pluto. So we call them dwarf planets or trans-Neptunian objects. So that was asteroids and comets. Now let's look at meteoroids. And a meteoroid is an interplanetary particle that passes through Earth's atmosphere. And it only switches to a meteorite if it does not burn up completely in the atmosphere and it hits the ground. So if it's in the air still, it's a meteoroid. But if it gets to hit the ground, then it becomes a meteorite. That's the only difference between those two. So here you see a meteoroid. I don't know if this is a meteorite, if it ever hits the ground or not. But that's what it looks like when it enters our atmosphere. Can you imagine driving that day and seeing that? How life-changing would that be? And still being alive. Like, this didn't blow up or anything. It burned up right there mostly. That's insane. And I just wanted to end the presentation. And wow, this is even shorter than I thought. I knew it was a short section, but here's a couple pictures of craters on Earth. These are old craters. This is a relatively newer one. None of us were alive when it happened, but still relatively new. Just to show you that, like, Earth, we have a lot of these, actually. It's just that we have a lot of processes that kind of cover it up. For example, we have wind and water to kind of smooth out the craters, so we don't see a lot of them, but they're there. We have a lot of craters on our surface. And that's it for chapter 11.